All right, so we're going to graph absolute value. And so the way that, the easiest way to graph an absolute value is to just pick some points and plug them in. Depending on the form that it's in, and we're just going to talk about one form today, and then we'll kind of add to it a little bit tomorrow. So today should hopefully be the more straightforward versions. But first, if you just had, I talked about this word the other day, like just f of x equals absolute value of x, that this is a parent graph because there's no numbers. There's no like 2 in front of the absolute value. There's no minus 3 inside of it. There's no plus 5 on the outside of it. It's just the starting like point for a graph. And so what this parent graph looks like, if I plugged in 1, the absolute value of 1 is 1. If I plugged in 2, the absolute value is 2. So if I plug in 1, I get 1. If I plug in 2, I get 2. If I plugged in 0, I would get 0. If I plugged in negative 1, the absolute value would make it positive 1. If I plugged in negative 2, the absolute value would make it positive 2. And so what we end up with is a V. Okay, so that is the parent graph. That's like the starting point. Now, when I put numbers into the problem, it's going to move the graph. Okay, so if we did absolute value of x and then plus 2 on the outside, okay, so you don't need to do like all 5 points like I did up here. We need to pick 3 numbers like we did on some of the lines. 1 positive, 1 negative, and then I always think that 0 is an easy like option, especially with absolute value graphs. A negative number is super important. Okay, so, and again, I like to pick 2, negative 2, and 0. Just spreads the graph out a little bit more. So if I put 2 in, well, absolute value of 2 is 2, 2 plus 2 is 4. And if I did negative 2, absolute value of negative 2 is 2, plus 2 is 4. And if I plugged in 0, absolute value of 0 is 0, plus 2 is 2. So 0, 2, 2, 4, and negative 2, 4. Okay, and so if you notice, these two graphs, they look the same. They're the same like width. It's just the bottom one, instead of starting at the origin, it moved up 2 spaces. Instead of, like on this one, instead of when you went to the right 2 and then you went up 2 spaces to get to that point, instead of going over 2 and up 2, it went over 2 and up 4. It went 2 more spaces up. And so if you think back to yesterday, when I said, and we were talking about the transformations, that anything on the outside of the parentheses, well, outside of the absolute value, was a up and down movement, and it was called a translation. So what you're going to have to do on the first set of problems is graph, and then also describe the transformation. So this one is a translation up 2. And I think it uses it actually says vertical in the book. So it is good, like that's the formal vertical translation up 2. Okay, so remember that anything here on the outside is going to be a vertical translation up or down. Up to, if there was a -3, it would be down 3. If it was a +5, it would be up 5. Okay? Alright, so yesterday, from the last one, our parent graph, it looks like that V starting like in the center, 1, 1, 2, 2, 3, 3, 4, 4, like if I did the points, they all match, right? So on then the original graph. Okay, the original one, there's our parent graph at the beginning, over 1, up 1, over 2, up 2, over 3, up 3, go. I mentioned the whole thing about like on the inside, we go the opposite direction. So if I put x plus 2 like that, so if you look back at yesterday, it said if there's anything on the inside that's being added or subtracted, it's a translation, and it was supposed to be to the left or to the right, but the opposite. So positive 2 would be to the right, but we said no, we're going to do the opposite, and it's going to be a translation left 2. I messed up the word again. Horizontal. Translation left 2. And then I would explain it later. So here's the explanation. Okay, so we're still going to pick our numbers. I'm still going to pick 2 to plug in, and I'm going to pick 0, and I'm going to pick -2. Okay, and so when I plug in 2, 2 plus 2 would give me the absolute value of 4, or just positive 4, so I can put that there. And when I plug in, shouldn't know why I went way over there, but if I plug in 0, I get 2, and the absolute value is just 2. And when I plug in -2, I get 0. Okay, so when I do this, and you're going to notice something that I kind of did on purpose, but 2, 4, 0, 2, and negative 2, 2. And it doesn't make a V. Okay? So, what that means is that you can tell that it's going down, right? Like if this one's, how far does it go down? Where does it go back up to make the V? So I need to pick a number over here. Like more like negative 2, or I can pick negative 3 or negative 4 or negative 5. I need to pick something over there to see, does it keep going down or does it start to go back up? So I'm just going to pick negative 3 because that's just the next number over. And I get negative 1, which turns into positive 1. So I plugged in negative 3 and I got positive 1. So negative 3, positive 1, and now it bounced back up. So I'm going to be pretty confident. Okay. So it still looks like the V, but it went to the, if you notice, it went to the left 2, even though it said plus 2 on the inside. Okay, it's the opposite. So there's kind of a visual of like why that worked. Okay, now if that's like, I started off with the translation to the left too for a reason. Number one, to kind of illustrate the point. But so I ended up having to pick another number because it didn't work out. I picked 2, 0, and negative 2. Okay. So really, when you have like this number in here like that, you actually want to pick a number like bigger and smaller than that number. So like I ended up picking negative 3 and it worked out. So you might end up, depending on how it works, needing to pick a few more numbers to make sure the V looks like it's supposed to. Okay. All right. Beginning. This one wider. Same. Let's look at another one. Kind of combine a couple things here. So there's two things that are going to happen on this one, but let's graph it, and then I'll come back to explaining the transformation. So I can still kind of go back to picking my 2, 0, negative 2. Okay, so I plug in 2. So the absolute value of 2 is just 2, and that means multiply, and I got negative 4. Okay, and then I'll plug in 0. So negative 2 times 0 is 0. And then I'll plug in negative 2. The absolute value of negative 2 is 2, and I get negative 4 again. Okay, so this is going to be different in a couple different ways, but I got 0, 0, and then I got 2, negative 4, and I got negative 2, negative 4. Okay, so two things happened on this one. So if we go all the way back to, well, it went down instead of up. So when we talk about our transformations, one of them is I have a reflection over the x-axis. And so if you remember from yesterday, a negative on the outside of the parentheses, on the outside of the absolute value, means a reflection over the x-axis. Okay? But then I also have this 2 right there. And you might look at it and say, well, that negative 2, that's like it all goes together. It does, but the negative causes the graph to do one thing, and the 2 causes the graph to do something else. Okay? So if you notice, this graph is skinnier, and that one's skinnier. Okay? And what happens, so remember we said because of the reflection, instead of over 1, up 1, we would go over 1, down 1, or over 1, down 2. Well, it's going farther, right? Like the point ended up, instead of 1, it went 2. Instead of 2, it went 4. So it's getting farther away from the x-axis. Okay, so if you go back to yesterday, a number in the front that's being multiplied meant a vertical stretch by 2. Okay, because it's stretching out, it's getting farther. Like if you stretch a rubber band, it gets longer. Okay, it gets farther away from, like, so you just hold, a rubber band, one part in your left hand and one part in your right hand, and you pull with just your right hand and you leave your left hand alone, or vice versa. The rubber band's stretching out, it's getting longer. It's getting farther, your right hand's getting farther away from your left hand. The points are getting farther away from the x-axis. They're stretching. How much? Times 2. If that was a 3 in the front, it would be stretched by 3. Okay? All right. Mount. So let's look at one more. So when you have a fraction, it'll only be in the front. They won't put fractions on the inside of the absolute value. Okay? You're going to pick the denominator. Positive and negative. And then another number, 0. So if that was 1/3, pick 3 and negative 3. If that was 1/4, pick 4 and negative 4. It's just way easier when you plug it in because the fraction will disappear. If you don't pick that, you're going to end up with a fraction. Just makes things a little bit harder. Okay, so this one we do end up picking like 2, 0, and negative 2 like I have in most of the problems. But again, if that was a 3, pick 3 and negative 3, and then you could still do 0. Alright, so when I plug in 2, remember this means multiply, so the absolute value of 2 is just 2, so if I put over 1, everything just reduces and we get 1. If I pick 0, absolute value of 0 is 0, 1/2 times 0 is 0. And then if I pick negative 2, absolute value is positive 2, and I do the reduce thing. Should be 1 lines. And I get 1 again. So here's my points. 2, 1, 0, 0, negative 2, positive 1, and it got really wide. Okay, so again, so this one, we went over 2 and up 1. So instead of over 2, up 2, you know, the parent graph puts us up here and up here. Okay, so like the red one is the parent graph, and the black one is what we just did. So instead of the distance from the x-axis going up to the red graph is our beginning point, it didn't go up high enough. The distance got smaller. Okay, so this would be a vertical, because up and down is vertical. It shrink, the distance got smaller, so it's a vertical shrink by a half. So, you know, we can still use, we still just use that number. But if you remember from yesterday, the half, anything in the front is a stretch or a shrink, and by the whatever number. Okay? Alright. So you'll have actually 8 problems to graph and to describe the transformation. Okay, the other problems, it's going to ask you to compare to, I'm going to actually use the exact problem or example from the book. Okay, compare to that graph. So basically, if I gave you another one, what is different? Well, the -6 is the same. So the 3 is the difference. And a 3 on the outside means translation down 3. Keep forgetting. Vertical translation down 3. And so that whenever you see the word compare, it's talking about doing transformations. Compare this one to this one. Oh, well, this one, it's the same graph, it just goes down 3. Okay. If I had here's the difference. Vertical shrink by 1/4. All right. So here's kind of a summary of all the transformations. Okay, so so you could have a number in the front. Sometimes they use like an A for that. You could have a number on the inside, and Y, let me use the right form. It's a minus instead. They use this H and K, and there's not like a great answer as to why. It's just, they're just a placeholder for numbers. Okay, so remember that this number right here is going to be a translation left or right, but opposite. So a positive would go to the left and a negative would go to the right. Okay. This, a number that's adding or subtracting on the outside, is a translation up or down. Positive goes up, negative goes down. Okay, this one is going to tell you a vertical stretch if bigger than 1, or it's a vertical shrink if between 0 and 1. So for the most part, if it's a fraction, but if you have an improper fraction, then it's bigger than 1. So be careful of that. Okay, and then the last thing that is possible is maybe there's a negative sign in the front. And that would tell you that there's a reflection over the x-axis. So it's not, you won't see all of these in the same problem. That would be ridiculous. We might eventually get there, but not till like second semester probably. Okay? But if this is a great, screenshot this, save it. This is a good picture to work on and memorize, because some of your problems will have just a number where the K is and there'll be nothing else. Oh, translation up or down. Gotta keep forgetting to do this. This is vertical and horizontal. I always forget because to me vertical means up and down, so it's redundant. Vertical and then up, saying the same thing, but that's the way we need to write it. Horizontal translation for the number on the inside, stretch or shrink on the outside, and a reflection. Technically you could have a reflection over the y-axis, but we won't see those for a while, so we don't need to worry about that. Okay, but this is a great picture to look at. Save it, copy it down, for your own notes to have. I would highly recommend on just one sheet of paper, write it really big. Write this whole thing on one sheet of paper and keep it, save it. So when you're working on these, this is what you should study for a test. Where if there's a negative sign in the front, that's a reflection over the x-axis. There's a number in the front, that's a stretch or a shrink depending on the number. Oh, there's a number on the inside, that's translation left or right, but the opposite of positive means go left, negative means go right. Oh, that's a vertical translation up or down if there's a number after being added or subtracted. Okay, this is a perfect thing to study. So write this down on a big sheet of paper, make it the only thing that's on that piece of paper so there's nothing else to confuse. Okay? Alright, we're going to do some more of this tomorrow, so don't I don't expect you to necessarily have it down perfect, but we got to get started on it. Alright, have a good rest of your day. We'll see you tomorrow.